Hey everyone. Hey everyone, this is Guru. In this workshop, we'll be looking at how Waku is uncompromising Web3 communications at scale. So, introducing Waku, it's a family of robust, censorship-resistant, and private family of communication protocols designed to enable privacy-first messaging applications. When I say messaging, it's not restricted to chat, but anything within the space which requires multiple parties to communicate with each other. So the six main values of Waku are: it's private, out of the box; it's censorship resistant, meaning that the messages in the network cannot be censored by any centralized stakeholder. It's also modular, meaning that it can run with any blockchain. It's something that complements a blockchain but not a blockchain. It's also adaptive and can run in any device, in your mobile phone or in your browser, even in a DApp node or a big cluster. So it's adaptive to any bandwidth. And it's also securely scalable. We use sharding to scale it across multiple devices and multiple content topics. It's also rate limited. We have a technology called RLN, which I'll be showcasing in a couple of next slides. So it's completely decentralized, and we are one of those protocols with a completely decentralized stack of rate limiting. Talking about the history, it all started in 2013 with the Ethereum white paper, when the holy trinity of decentralized web was introduced. So Ethereum was for consensus, Swarm was for storage, and Whisper was for generalized messaging. But there were not much of dedicated teams building on top of Whisper. So in 2019, we started building Waku V1, and 2020, Waku V1 replaced Whisper in the Status app. So this was a huge benchmark because Status app is one of the well-known communications app in the Web3 space. And today, Waku has evolved into a standard for Web3 communication. So we have a vibrant ecosystem where we have Status, who is a Web3 messaging app. Railgun is a privacy layer built on top of Ethereum. The Graph is also using Waku for decentralizing its indexers and a couple of more use cases. And XMTP is also built on top of Waku for this specific use case, which is chat messaging. So the key features of Waku are it's adaptive. As I mentioned earlier, it can cater any kind of resource restricted environment. So on the left, you have clusters which have more bandwidth, and on the right you have browsers which have very less bandwidth. So we have different implementations for each of these different resource restricted environments. And it's also rate limited. We have rate limiting nullifiers, which is a truly decentralized anonymous rate limiting technology with ZK proofs. So we have a membership contract on the blockchain which can basically find if Alice is trying to spam your network or if Alice is trying to DOS your network. So DOS protection is something that we've been working on over the last couple of months. And it's also open and permissionless network. We are built on top of libp2p's PubSub, so Gossip Sub. So it's a fleet of nodes running the PubSub topic architecture. So we have a lot of content topics within the Waku network. So it's basically like users can push messages into any content topic and also subscribe to content topics to retrieve messages. So we have three key protocols, especially for hackers to target during ETHIndia. The first one is light push, which can be used for pushing your data into a content topic. Filter can be used for retrieving data from a content topic. And store is basically a temporary storage protocol. At this point, I also wish to mention that store is not meant to be exploited. It's not something for long-term storage. So since Waku is a communications protocol, it's better to use something like IPFS or Codex for maintaining your long-term storage needs. So getting started with Waku, you have two ways of doing it. You can either operate a node and contribute to the Waku network, or you can build on top of Waku. So operating a Waku node might be a bit off topic for hackers, but then in simple words, we have three different implementations and ways of hosting your own Waku node. You can use our nWaku, which is available. We have binaries available on GitHub, and we also have a Docker Compose command for you to get started without much friction. And we have a DApp node integration as well, so you can run your own Waku node in a matter of few clicks. And building on top of Waku is where we focus for hackathons. So we have different Waku SDKs like JS Waku, which is our JavaScript implementation. nWaku is a NIM implementation, Golang implementation. We also have Rust bindings and C bindings. So yeah, coming to the resources, We have a developer documentation at docs.waku.org. So this will be a holy grail to get started with Waku, and it has pretty much all about the protocols and use cases about Waku. And we also, all the code is open source on GitHub, so you can find all the examples on GitHub as well. And we have examples.waku.org where we have like around 5 or 6 examples that use Waku's protocols. So it's a pretty good place to get some references. And all the research articles and RFCs will be available at rfc.wac.dev. So we have all the RFCs available, and it's been, it has a repository of work of over last 2 or 3 years. So definitely check it out. And for ETHIndia, we have bounties worth $10,000. So the grand prize winner will be bagging $4,000 for the overall best implementation of Waku. We also have 4 different track prizes. We have best network state goods using Waku. We have most innovative project using Waku, and best privacy focused project using Waku, and a track dedicated for gaming and marketplaces. So about the bounties, all the bounties are focused to non-chat projects. So we are not really encouraging chat projects at this point because we have a lot of chat projects around Waku already. So some of the example use cases over here will be gaming. So you can build games with Waku where you make all the game state communications through Waku. You can also build decentralized marketplaces where, for example, if you are building a NFT marketplace that can have elements of Waku and that can decentralize the centralized parts of the currently available marketplaces to a great extent. And also state channels is something that a lot of hackers have been building over the last few hackathons. So that's an important use case as well. And it's basically like you can build anything related to communications with Waku. And you can check out more ideas about Waku, around 50 ideas that we curated for hackers to check out at ideas.waku.org. You can also scan the QR. So also shout out to Waku's network launch. We just launched our network a day ago. So make sure to tweet it out, help us amplify the announcement, and come to our booth for getting some swag. And yes, you can join us on Discord. We have some active conversations going on over there. So after this, we'll be building something simple with Waku in the next few minutes. So I'll have my colleague Sasha joining me.
So this is the game. Let's create a new one. So the game has been created. Let's go to and join it. So now we are joining, take some time. We are using the test fleet here. So please expect some delays. There is a production fleet with better timing. So here it is. It says like open and turn. Let's do this. So I'm in the opponent tab, and I do the turn. So as simple as that. If you continue, this will be like a tic-tac-toe game. Everyone knows it. I won't continue. So I will show you the code, the most important part of it, and I will introduce you to React hooks. React hooks have the naming of. Everyone sees the code. It's okay. Yeah. So it's named like simple as Waku/React. I just install it, and first thing that you need to do is to create an abstraction to connect to the network. And we call it a node. And a node that operates over the light protocols is called light node. Light protocols, as Guru said just now, it's light push, filter, and store. So here we configure the node. And I advise you to use this default bootstrap, which allows you to connect to available nodes in the network. So it does a job for you. If you want to experiment more, you can run your own node and connect to it by using a multi-address. It's very straightforward. Come to our booth, we will help you with some edge cases if you might notice. And here we mentioned protocols that we want to use. And again, these are the light protocols. They may be mentioned. If you don't mention them here, the light protocols by default will be used. So this is a holy trinity of light protocols here. This is the provider, React provider. What it does is that just puts this abstraction into React rendering tree, and then we just get it. Let's say we created the game, and another thing to mention is that Waku operates over, it is unbiased and it is unopinionated. So it just takes care of transferring bytes from endpoints, which means that we need to create encoder and decoder to read from this stream of bytes. And for that, we have also a solution which is called content pair provider. It creates an encoder and decoder for us, and it puts into the context as well. So you just take it, as simple as that. And what we operate over is a content topic, and content topic is the abstraction that you should familiarize yourself with, and it allows you to send something to some particular place. It's like a room right now. I'm broadcasting some messages to you, and it could be like one content topic. I may want to broadcast a message to someone here in particular, but overall everyone hears it. This is how Waku works in a nutshell. And yeah, so we created encoder, decoder. Let's go to the juicy part. So here I'm highlighting the line where we are getting the abstraction from the network, and we might do something with this. In this particular case, we are passing it, we are using it to retrieve messages. And there are two ways to retrieve messages. One way is to retrieve messages ad hoc. This is called filter. We essentially subscribe to the stream of messages which are happening after we started the subscription. And in this line, we essentially subscribe to it. There is a hook, it does it for you. It will start iterating and it will be keeping updating the messages. You just get it. And as well as the second way to get the messages is the store. And this allows you to get messages which were there exchanged in the network while you were offline. So to do that, there are 3 lines. So essentially like this. Later on, we can do some stuff with messages. We might want to combine them together and like get only one blob of messages and then iterate over it. This is very straightforward. And okay, what we can do else? Now we have a way to get messages from the past, get messages from recent, like from now, and now we want to send the messages, right? So to do that, there is a hook. It's called light push, and what it does is that you just throw in it some here is this line. You get the push function. What it does is that it receives payload and some timestamp. What it will do beneath this abstraction, it will create a protobuf for us, which follows the Waku message convention protobuf, and essentially an entity in the network which is exchanged everywhere. This is the language nodes speak to each other. And there is one field reserved for it, and which is called, I will show you. So please refer to this site if you have any questions, or to us, of course. Yeah, let's go. So learn here. So content topic. There is more information about content topic. It follows some convention, so please don't break it, because otherwise the experience might be working, might be not. No one guarantees. This is short description of protocols. We covered here filter, store, and light push. There are some other protocols. If you are curious, come to us. We will educate you on these primitives. And the Waku message. Waku message is as I said, this is entity in the network. This is universal language we speak. It consists of content topic, the place where we want to send messages, and the payload. And payload is the place where we put our information, just bytes. You can do encryption on top. You might do it, you might not. Other things that you might want to consider is to check out the other places in our documentation. I showed you right now how to use Waku React hooks, but if you want to have like a little bit of more of complexity, you might want to do some tricky stuff. I don't know, like maybe writing into some database, writing to some fancy cache messages, like rebroadcasting it, maybe using some conflict-free data structures. For that, maybe a better way to use is to import the Waku CDK package. And Waku CDK package has like role abstractions, which you need to use in order to achieve the goal, whatever you want, you have in mind. And please come to us again. We will help you. So this is our job today. Yeah, this is pretty much it.